This is Tech Math 2, and we're in section 5-3 today. And the issue is, if I have the sum of two squares, or I have the difference of two cubes, difference of two cubes, sum of two cubes, I should be able to factor that. So the first guy is going to factor x plus y, the second guy x minus y, times x squared minus xy plus y squared, x squared plus xy plus y squared. Now, both of those formulas are in the front cover of your book, so if you ever get confused of what they should be, you should just go and do it. Now, we're going to go the other way to make sure that it works. So if I have x plus y times x squared minus xy plus y squared, and I say, well, x times x squared, so that's x cubed minus x squared y plus xy squared plus x squared y minus xy squared plus y squared. And we can see that these two guys go away, those two guys go away, and all I have left is x cubed plus y cubed, if I would have put a cube there. Likewise, I could show the same thing if I took the x minus y guy and multiply them through. I could get the same thing. Okay, so those are the two new things we're adding to our lexicon of math. Now we're going to move down and start working problems. And it was Nate that was amused that the class actually started on time. Totally befuddled him. How could that happen? The normal start times are like 3 after and 4 after and 5 after. And I had one of the videos started at 18 after that I'm encoding right now. So this is unusual, I have to admit. So I've got a m plus n minus b m plus n. And right now the class is asking, what does that have to do with the difference of the sum of two cubes? I don't understand. And it has nothing at all to do with that. It has to do with factoring things. So we're going to factor this a minus b times m plus n. And you can see if I multiply it out, I can multiply it out. And I'm going to do number 2 next. M x squared minus 16, 3 x squared minus 16, and we can factor that and get m minus 3 x squared minus 16. And then we recognize that x squared minus 16 is really x squared minus 4 squared, so that's the difference of two squares. So I can continue my factoring and say m minus 3 x plus 2 x minus 2. Well, I could, but if I did, I'd be wrong, right? So we'll get rid of those guys. X plus 4, x minus 4, that's better. Okay. Maybe starting on time is not such a good idea because the instructor can't do much. All right. Has to warm up. That's what we're going to do 3 to warm up. mx plus my plus nx plus ny. Well, it looks like I can pull a m out of something, and I can pull an n out of something. And if I do, that thing that I'm pulling it out of is xy. So it looks like I'm done with that guy. Okay, we'll drop down to 7. Yeah, we'll drop down to 7. I don't know. We're going to drop down to 7, but I'm sure I can write the problem down right. 7. 6x cubed, 4x squared, 3x minus 2. Well, it doesn't appear to be the difference of two cubes or the sum of two cubes. So that means it must do something like that. And I'm probably going to need a plus 1 and a minus 2 probably. But how am I going to get Okay, so if I have something x squared plus 1 and I have something x2, and I put a 2 here, that'll give me 4 of them, right? But if I put a 3 here, that'll give me 6 of them, and if I put a 2 there, that'll give me a minus 2 of them. No, that doesn't do it. I have 6x squared, I have minus 6x, I have 6x cubed minus 6x squared, which is wrong, plus that. Okay, so the 3's got to go there, the 2's got to go here. All right, now I've got 6x cubed minus 4x squared, x that, and okay, now I'm right. So when in doubt, trial and error. 2, 3. And now I see that that guy's right, that guy's correct, that guy is right, that guy's... Okay, got number 7. Moving on to number 10. Number 10. This looks like a squared minus b squared type of guy. All right, so we're going to have x minus y squared minus 4a squared squared. And that way, we're in the right form. Okay, so I've got x minus y plus 4a squared times x minus y minus 4a squared. And can I do anything about that? And the answer is no, can't do much about that. So we'll move on. Look at 12. Nine a minus 4. That's nice. You have a 9 and an a in the same problem. Way to go, awkward. Minus 64b to the 4th. Okay, now we're sort of thinking that this is a squared minus b squared again. So if I rewrite this as 3a minus 4 squared minus 8b squared squared, then I'm in the form of a squared minus b squared, and I factor a, 3, a minus 4 plus 8b squared times 3, a minus 4 minus 8b squared. All right, so that was okay. As long as I recognize the form, then I should be all right. We'll move down to 15. 4x squared minus 4y squared plus 4y plus 1. Well, you know, we do have something here that's in the form a squared plus b minus b squared. But I don't think that's what they want us to do. I think they probably want us to factor it. I'm going to need a 1 and a 1. But if I have a 1 and a 1, how am I going to get the other guys? All right, well, this one seems to be quite easy. It looks like we're going to need three terms. Probably a 2x and a 2x. And probably a plus 2y and a minus 2y. But then the issue is, how do we get the 1? And so that's the issue. How do we get the 1? Because there's the x 2x squared. That term goes away. But if I put a minus 1, well, if I go minus 1, then I can have a 1, right? Okay, so if I do that, I've got this term right there, and I've got that term right there. I've got the x term does not go away. I still have a 2x term sitting there, and I still have but the y term's correct, but the x term is not correct. Now, oh, I see the problem. Anybody else see the problem? Yeah, I see the issue. The problem is that the instructor failed to write the problem down right. So if we look back in the book, we have 4x squared minus 4y squared plus 4y minus 1, and now that solves all of our problems, because now we can have a 2x plus 2y plus 1 and a 2x minus 2y minus 1. And now I've got the x squared term. I've got the minus 4y squared term. I got the minus 1 term. The 4x term goes away. The 2y term goes away, and everything's fine. But I still have a problem with 4. I still need 4y. Okay, so I'm going to put the minus sign over here and the plus sign over there. See if that works. Now, if I do that, I end up with 4x squared minus 2xy plus 2x. I need a minus term someplace. Where do I need it? Right there?
Yeah. You said you were going to switch it.
Yeah. Then I didn't do it. And then I had a plus 4xy. That's a 4. I got a minus 4y squared. And then I've got a plus 2y. And then I've got a minus 2x plus 2y minus 1. All right, so this term goes away. Those terms go away. I have 1, 2, 3, 4 guys left, which are the exact 4 that I have up there. All right, so the issue is, write the problem down properly the first time, and then problems will go away as you proceed down to solve the problem. All right. 15. We just did 15? Well, I thought I could get away with doing it again because it went so well. Minus a squared minus 2ab minus b squared. Okay, it looks like we have maybe a 2 and a 2. No, that won't work. It looks like we have 3 terms. We have 3 terms in each one again, right?
Mm-hmm.
That's what it looks like we're going to need to do. So we'll go with a 2 and a 2. And minus a minus b, 2 minus a minus b. All right, so if I do that, plus, plus. All right, so that's what I'm going to try. Okay, so I got a 4. I've got a plus 2a plus 2b. I've got a minus 2a minus a squared minus ab. I've got a minus 2b, a minus ab, and a minus b squared. Alright, so now let's see, what can I get rid of? I can get rid of these guys. I can get rid of those guys. There's the 4 I need. There's the minus a squared minus b squared I need. And there's the minus ab that I need. Alright, so once I recognize that I need to have 3 terms in each one, I have a fighting chance of getting it correct. Until then, I'm sort of hosed. Okay, so that was 16. We'll turn the page. Okay, we'll look at 17. Doing so well with these guys. X plus y squared plus 13 x plus y plus 36. I think I'm going to do something weird. Do I do something weird every now and then? I'm going to do a substitution. I'm going to let u equal x plus y. And then I'm going to have u squared plus 13u plus 36. Now 36 factors 4 and 9. 4 plus 9 is 13. U plus 4, u plus 9. And then I'm going to go and undo my substitution and say x plus y plus 4 and x plus y plus 9. See how that works? Yeah. Now the issue is on my right. That's the issue. That looked pretty intuitive, you know, when you look at it. Okay, so I've got x squared plus xy plus 9x plus xy plus y squared plus 9y plus 4x plus 4y plus 36. Well, isn't that special? And that's supposed to be the same as this. Okay. So I've got x squared plus 2xy plus y squared. Okay, so that's that guy, that guy, that guy, that guy. And then I've got a plus 9 x plus y, and then I've got a plus 4 x plus y, and then I've got a 36. I recognize this guy as x plus y squared, and over here I've got 13 times x plus y plus 36, and that is exactly what I had to start with. So why didn't I think about using a substitution before, and which probably would have worked just as well in those earlier problems as well, but that's what math majors do when they can't do anything else. They find some substitution that makes the problem easy. 3x minus y squared 14x minus y plus 8. We're going to do the same thing. We're going to let u be x minus y and rewrite the problem 3u squared minus 14u plus 8. Why are we using u? No reason. We could use anything at all, right? Yeah, we did. Yeah, so X, Y, Z. We're not going to use X, Y, or Z, right? So we'll use U. It comes before X. Yeah, why not? All right, so now this guy factors probably 3UU. Now if I go minus 4 minus 2, then I get 12 minus 12 minus 2 is minus 14. So that factoring works. Now I'm going to unsubstitute. So I've got 3 x minus y. What am I doing? I don't know what I'm doing. It's hard to say. I've got 3 x minus y minus 2 times x minus y, too many parentheses, x minus y minus 4. And then, okay, so that'd be factored completely. So I'd probably just leave it that way. I probably wouldn't multiply the guy back in. Should we multiply it out and see if we're right? No, okay, we won't do that. All right, we'll drop down to 22 and finally get a problem that's in the chapter. 22. 27x cubed plus 8y cubed. I recognize that as 3x cubed plus 2y cubed, which is the sum of two cubes. So the factorization will be 3x plus 2y times x squared, which would be 9x squared, minus x and y, so it'd be 6xy, plus the other guy squared, 4y squared. And then I'd be done. So if it's the difference of two cubes or the sum of two cubes, there's no factoring the guy left over. He's not going to, that guy, that 3-term guy, there's nothing there to factor. The 2-term guy, there could be something to factor in there, and I'm sure we'll run across a problem like that sometime. Okay, we'll look at 23 x cubed minus 64. I recognize 64 is 2 to the 6th power. Do I not? Yes, I do. So this is going to be x cubed minus 4 cubed. All right, so I'm going to factor that x minus 4 times x squared plus 4x plus 16. Okay, so I'm using the form x cubed minus y cubed equals x minus y, x squared plus xy plus y squared. So that's all I'm doing. I'm just using that form and writing it down and saying, how happy am I that it worked out? Okay, we'll do 25 next. A cubed b cubed plus c cubed. So I'm going to write that ab cubed plus c cubed, and I'm going to say my factorization is a b plus c times a squared b squared plus minus abc plus c squared. And I am done. That's all it is. We'll do 28. 28? Oh yeah, we'll do 28. Did I miss one? Did I do 16? I was supposed to do 16. Did I do it? Yes, I did. I think I did. I don't remember. Let's move back. I did 16?
Yeah.
All right. Not that I don't believe you or anything. Yeah, I did. All right, good. Okay, so now I'm doing 28. I see 28 as 2a cubed plus b cubed. So I write down my answer, 2a plus b times 4a squared minus 2ab plus b squared, and I'm done. And we'll do 30 next. (64x to the 6th minus 125y cubed). Okay, so I recognize that as 4x squared cubed. 4 cubed is 64, right? Minus 5y cubed. I recognize 125 as 5 cubed. Alright, so that being the case, 4x squared minus 5y times 16x to the 4th plus 20x squared y plus 25y squared. So I'm just dumbly following the form I'm supposed to follow, and I come up with the right answer. Or I come up with an answer and I declare it correct. Yeah, whichever one it is, right? We don't, not going to be picky about that. Oh yeah, we are. I mean, if it's wrong, it's wrong. But yeah, other than that, I mean, number 31. 27a to the 6th minus 8b to the 9th. Okay, now because we're in this section of the book, we think we see the difference of two cubes. So that's 3a squared cubed minus 2b cubed cubed. Okay, so now we're all set. We factor it 3a squared minus 2b cubed times 9a to the 4th plus 6a squared b cubed plus 4b to the 6th. And then we ask ourselves, can we factor anything else? And the answer is no, so we move on. Number 32, we have 2ab squared cubed plus 5c to the 4th cubed. No, that's not what the problem has, but that's what we're going to write down because that's what we need, the sum of two cubes. So our answer is 2ab squared plus 5c to the 4th times 4a squared b to the 4th minus 10ab squared c to the 4th plus 25c to the 8th. Now, I don't recall any real-world application where this particular problem applies. Some of the other ones I do, but this particular case, c could be the speed of light, I suppose, anyway, that's just one of those crosses we have to bear. Okay, 33. Now, back in the good old days when I made up my own problems for the test, this would be something that I'd have on the test. But it'd be slightly more complicated than this. Because this is a interesting problem in that it has two answers, both of them equally okay. So if I say I'm going to arrange this to be the sum, the difference of two cubes, and I say this is x squared cubed minus y squared cubed. Okay, so I could do that. And then I'd say that this is x squared minus y squared times x to the 4th plus x squared y squared plus y to the 4th. And then I could say, well, I can factor this guy, and I can have x plus y, x minus y, times x to the fourth, plus x squared y squared plus y to the fourth. Or I could say, you know, I really have the difference of two squares. So I have x cubed squared minus y cubed squared. And then I could say, well, that factors x cubed minus y cubed times x cubed plus y cubed. And then I could take this and say, well, this is x minus y times x squared minus xy plus y squared, that'd be a plus xy plus y squared, times x plus y times x squared minus xy plus y squared. And now I got 1, 2, 3, 4 factors sitting there, and the first time I only had 1, 2, 3 with no way at all, no earthly way to factor that guy, right? Yeah. So I have two different answers that have to be the same. But I'm really hard pressed to be able to factor that guy, especially seeing that I told you can't factor it, right? Yeah. But yet, if I go and I multiply that guy with this guy, I end up getting him. So that's just, oh, isn't that cool? Just one of those things that, just another cross you have to bear. You know? Two different answers, both of them perfectly okay. But you could sit at this guy and scratch your head a whole long time before you figure out how that guy's going to factor. And until you see the other way, and oh yeah, she clearly has to factor that way. Yeah. Clearly it did. I can tell. Number 34, and then we'll have to quit because we ran out of problems. This guy's got two answers too. So I could say he's a squared b squared cubed minus c squared cubed. And then I could factor him a squared b squared minus c squared a to the fourth b to the fourth plus a squared b squared c squared plus c to the fourth. I could do that. Or I could say he's really the difference of two squares, a cubed b cubed squared minus c cubed squared, and then I could factor him a cubed b cubed minus c cubed a cubed b cubed plus c cubed. And then I could go and factor both of those guys, a cubed b cubed. Not like that, I couldn't. Maybe if I change colors, I'll change colors. Okay, so a b minus c times a squared b squared plus a b c plus c squared times a b plus c times a squared b squared minus abc plus c squared. So I could do that. Again, two separate answers, the same exact answer to both of them. It really doesn't matter. Now, if I had a graphing calculator of the TI 85, 86, 89 variety, it will do these factorizations for me. So that's also a possibility. So those of you who are planning someday to proceed to Calculus 1, 2, and differential equations, this is the right time to buy a better calculator. And so that you use it and you know how to use it, so when you get there it's not a problem. For those of you who still have your TI 84s, anybody still have a TI 84? Remember that is an 8th grade calculator and won't do anything for you when you get to calculus. So a total waste of money, and you can throw it away. You give it to a younger cousin anytime you want. You really do want a engineering calculator, which a TI-85, if you can get it from your dad, would be really cool. But they don't make them anymore. But the TI-86s and 89s are still being made, and those are the guys that these guys will solve differential equations for you. Let alone do the integrals, the differentiation, multiple problems, multiple unknowns, linear algebra, all kinds of other cool stuff. Of course, they do come with 650 pages of instructions. So make sure that when you spend the money to get one of them, keep the book with it. Never displace the book from your calculator. They should be in the same spot. Okay, any questions? If not, we will take attendance.
I don't think they allow
I didn't, didn't we? They didn't do it in 8th grade when you were in 8th grade? They didn't even allow a calculator in class? That's a definite mistake. In 1996, that's a long time ago, right? My third daughter went to the Coast Guard Academy with a TI-86. That's how old the TI-86s are. 5 years later, my youngest daughter goes to the University of Connecticut with a TI-89. And now one's a